Hello and welcome to problem 2 for vectors. We will be continuing off the original ambiguous sign law case with the help of my lovely friend here, Mark. We don't have to worry about it. He's going through a bit of a phase right now. But in the meantime, let's get into the problem. So, problem 2. We have to solve for the resulting vector of vectors A and B. A and B representing what sides A and B were originally, just flipped now. A being B and B being A. It's not too complicated, don't worry about it. Vector A is 5 kilometers north, 48 degrees east, and vector B is 2 kilometers east, 10.53 degrees south. With these lovely mathematics, we can actually solve for, it all here. I'm just going to make sure that's nice and labeled. So now we have, in here, just a reminder, this is 42 degrees. That's 48 plus 42 is 90. So that is 42. I'm just reminding you what that actually is. So that way you don't be like, what is this? What is that? I'm telling you what that is. It's 42. So we can actually add 42 and 10.5 degrees. And 10.553. And we get, I won't worry about the math, but it's 52.53. Quite lovely. Not the cleanest number, but it is quite lovely. So now, I will be solving this using the parallelogram method, meaning that this comes over here, which means I'm cutting through there, and this side is also reflecting on this side. I now need to solve for these resulting angles, just the one, and both will reflect to each other. And I also need to solve for this. Luckily though, since both of these are 52.53, I just need to divide 52.53 by 2, by half. So taking my handy dandy calculator, 52.53 divided by 2. Well, that's a big fraction. There we go. 26.27 is the resulting vectors within here. I'll just write it down here. 26.27 degrees. Lovely! Yippee! So now that we know what these angles are, we know that roughly with a triangle, all angles inside must equal 180 degrees. So if we know that it's 26.27-ish, that means we can just multiply this number by 2 and then minus it with 180, getting the resulting A angle that we need to solve this problem. So let's do it. Times 2. Boom. Another big fraction. We don't like that. Ooh, 52.53. Amazing. Quite easy. Very simple. So now 180 minus the answer that we just got. That makes that 127.47 degrees. That's really big. I'm going to mark it right here. But now we do have that degree value, which is really nice. So now we know what, we'll say angle AB is. Now, since we already know what this length is, which is 2 kilometers, we can now use cosine or cos law to solve for this. We have all resulting parties needed to solve for, side length C, as it were. So let me write it out. So we are looking for c squared equals b squared plus a squared minus 2ac cos, 127.7. 127.47. Boop. So now we can plug in our numbers. So that makes this 2 squared plus 5 squared minus 2, 5, that should be a B, 2 cos 127.47 degrees. Yippee! Luckily, all of you should know what 2 squared is. It's 4 plus, what's 5 squared? It's 25. Minus, I'm going to do all this chunk on my calculator, so I'll get rid of that. So we'll start off with negative 2, 5, 2 equals negative 20. Very nice. And then we're going to cos, because it equals the same thing. It's the same multiplication. Cos 127. Press 4. 27.47. Very nice. I will press equals. That now equals a positive number, which means we get to change it. So which equals 12.39729. I'll say 12.17. We can now add all of this up. So plus 4 plus 25, that's 28. Whoopsie! Equals c squared equals 41.17. And now we get to square root both sides to get the proper answer for c squared, which now equals, hold on, 6.42 kilometers of a vector. And we can get a reasonable angle from this. So because we're starting from the little base marker here. This is 23. If this was the 26.27, we can add 48 to it to get the angle to make this prim and proper for proper vector form. So 26.48 plus, which makes this six. That is 74.27. Not 5. 74.27 degrees, which makes this final answer C equals 6.42 kilometers, bracket, always remember the bracket, north, 74.27 degrees east. lovely. Funnily enough, thanks to our cartographers and such at the building, we do know exactly where this is located on the streets. And sadly, this does relate to a few major problems. Sadly, the exact positioning of this, which I can't relate to you, was the same spot my partner, my old partner, got an unfortunate accident by someone who, cut off both his arm and his leg in such quick succession as if it was the cleanest cut known to anyone. He sadly lost his life. And it was only just for pulling over a drunk driver, which happens to be the spot where Vector A stops at for M, which makes M actually the most reasonable suspect. You wouldn't happen to know anything about that, Mark, would you?